Hello friends, my name is Samir Dokadia and today I will discuss about the aromaticity, non-aromaticity and anti-aromaticity. And this topic is very important for Csir-net, GATE, G, NEET and other competitive exam. So let's learn without cramming. First of all, what is aromaticity? Aromaticity means it is a property for cyclic and planar molecules with pi bonds in resonance that gives stability to the molecules. Means molecules have cyclic, planar and have pi bonds but in resonance. They are delocalized, okay? And delocalized system is always stable and having low energy. You will know very well about it, okay? So it is the definition. The molecule which have such type of property are known as aromatic compound, okay? So let's take an example. First of all, cyclohexane, which is cyclic but not planar, no any pi bonds, so it is not aromatic. And here you can see that it is not flat, okay, because all the carbons have sp3 hybridization, okay. There is ethene, which have pi bonds but they are not in resonance, flat or planar molecule, but it is not cyclic molecule, so it is not aromatic compound, okay. There is benzene. You can see here that it is cyclic planar because all the carbon have sp2 hybridization and it have also pi bonds that are in resonance, okay. So it is stable molecule and it is aromatic compound. But remember one thing, from this definition we have not determined that whether the compound is aromatic or not aromatic, non-aromatic, anti-aromatic. No, we should follow some rules. What rules? We will discuss about it. First rule is the molecule must be cyclic, okay. There are 4 rules and first rule is the molecule must be cyclic. Let's take an example here, that benzene and 1,3,5 hexatriene, pyrrole and buta-1,3-diene-amine. So benzene is cyclic, so it is aromatic compound, and 1,3,5 is hexatriene, it is a cyclic compound, so it is not aromatic compound, okay. Here I have not determined and mentioned that it is anti-aromatic or non-aromatic. We will discuss about it in later stage and we will solve this both of these example in later stage, okay. But here you can see pyrrole is cyclic compound and it both of benzene and pyrrole follows all the 4 rules, okay. So both are aromatic, okay. We cannot determine from the first rule, okay. They obey 4 rules, okay. Here buta-1,3-diene-amine is a cyclic compound, so it is not aromatic, okay. Let's go into the second rule. Must contain a delocalized conjugated pi system. What is conjugation and what is delocalization? So first of all we should understand about it, okay. So for conjugation, it is the overlap of 2p orbitals and these two orbitals are separated by 1 sigma bond. You can see here, okay. They must be parallel to each other, okay. So from this definition you can understand what is conjugation. It is simply overlap of 2p orbitals and which are separated by 1 sigma bond, okay, and they must be, these 2p orbital must be parallel to each other. Delocalization, you know very well. Delocalization means electrons are delocalized. We simply cannot determine where the electron is, okay. But here you can see the another definition, that delocalization means molecular orbitals that cover the whole system, not half, not partially, that covers the whole system, okay. How? Let's take an example here. You can see the orbital diagram of the benzene, okay. From this you can understand that all the p orbitals are unhybridized, okay. It have carbon that have sp2 hybridization, so there are 3 sp2 hybridized orbital that take part in sigma bond, okay. But here you can see the p orbital that are perpendicular to the plane of benzene or sp2 hybridized orbital, so it take part in making pi bond, okay. So you can see here that both the orbitals, all the orbitals are separated by 1 sigma bond and all are parallel to each other. So here you can see first this, okay. I am showing here from the red dot that this orbit, p orbit, make the bond with this carbon first, then this p orbital make with this, okay, pi bond like this, okay. You can see I am not showing the right animation, okay. You know very well that both the lobes of p orbital make the pi bond, but here I am only showing you the pi bond like this. Okay, so first this p orbital make the bond with this p orbital, and this p orbit make the bond with this p orbit. Okay, then what happened? This p orbit also parallel to this p orbital, you can see here. Okay, you can see with this p orbital and separated by one sigma bond. So it can also make the pi bond with this p orbital also. And also here you can see that this p orbital can also make the bond with this p orbital. Okay, here. So we will draw it like this. Okay, and also remember remaining is pi bond. So you can see that pi bonds are delocalized. Why? Due to the conjugation, and conjugation means simply overlap. Okay, but here you can see the p orbitals are separated by one sigma bond. So this p orbital and this p orbital also make the bond with the another p orbital, and they are also parallel to each other. So remember one thing, pi bonds are delocalized but due to the conjugation. Okay, remember this thing. So delocalization possible due to the conjugation. Okay, and you can see these orbitals or these pi bonds are covers the whole system by delocalization. Okay, you can see simply here like this. Okay, I'm showing you the animation and like this. If these two lobes are removed, okay, what happened? You can simply see that here the pi bond is, and here also the pi bond is. Okay, I'm showing another point here, that this p orbital make the bond with it, and also this p orbital make the bond with this p orbital. Okay, what happened if these two p orbital, you can see that also separated by one sigma bond, so this p orbital also make the bond with this. Okay, like this. Okay, I'm removing this pi bond. Okay, and what happened, this p orbital, you can see here this, okay, can also make the bond with this p orbital like this. So I'm removing it. Okay, and remaining p orbital, that cannot take part in any of the orbital. Okay, because two p orbital overlap with each other. Okay, so you can see here simply that pi bonds are delocalized but cannot cover the whole system. Why? Because here we have removed two lobes. Okay, and this p orbital and this p orbital cannot overlap because they are separated by two sigma bond, and there is no conjugation here. Okay, so conjugation covers the only partially system. Okay, so delocalization happen here. Okay, but not in the whole system, but only a partial system covered by the delocalization. Why? Because conjugation covers only a partial system. Okay, so these pi bonds are delocalized but in the partial system. Okay, not in the whole system. Okay, you know very well about it, what is delocalization and why the conjugation is required. Okay, so simply we remove it. Okay, I hope you understand about it. Okay, so let's take the image of the benzene ring in which pi bonds are delocalized like this. You can see that we cannot determine where the electron is, where the pi bond is, so we simply draw the structure like this in which pi electrons are denoted as the pi electron cloud. Okay, so it is the very 3D structure, and also it can be, you can see it from the X-ray diffraction method and another analysis. Okay, so it is the right structure of the benzene. You can simply see it from in a video, in animation video. You can see here that pi bonds are delocalized. See, okay, in the 3D structure also you can see that pi bonds are delocalized. Okay, so you can simply draw the structure that pi electrons cloud. Okay, and for conjugation, you know very well that available p orbital is required. Okay, p orbital must required for conjugation. Okay, there are that which p orbitals that are parallel to each other and separated by one sigma bond. Remember this thing. And second, a lone pair or carbon pair or negative charge on carbon atom or any of the atom. Okay, and carbocation which made by the simply carbon is connected to the electronegative element, and when electronegative element removed, carbon will get positive charge and also positive charge on any of the atom. Okay, so simply such type of three rules and 3 things are required for conjugation, you know. Okay, you should remember it, and we will discuss in the examples also. Okay, but first we should understand what the third rule is. Okay, third rule is that the molecule must contain 4n plus 2 pi delocalized electrons. Remember this thing, delocalized electrons. Okay, and where n is equal to 0, 1, 2, 3 integer values, okay, and 0, this is known as Huckel rule. Okay, so aromatic compound must follow this rule, so they will be aromatic. Another is the molecule must be flat. Okay, usually it is true for molecule which obeys first and second rule. Okay, you can understand that first rule is cyclic, okay, and second rule is conjugated system. You know very well that in conjugation we required p orbital that are parallel to each other, and when they are parallel to each other, when the carbon will have sp2 hybridization. Okay, when sp2 hybridization carbon is exist, the system will be planar. Okay, and planar molecule is required here because flat system is required here. Okay, so you can understand first and second rule. Usually when molecule obeys first and second rule, the fourth rule also obeyed by the molecule. The next topic is about pi electrons counting. Okay, so pi electron counting means we should count the pi electrons. But what pi electrons? We have negative charge electrons, so we have lone pair, but which electrons we should count? This is all about the rules. Okay, let's go to the first rule. If the molecule contains the pi electrons and lone pair, consider the lone pair also, because this lone pair take part in conjugation. Okay, and also consider the Huckel rule. Why and how? Let's go into it. Okay, I know you can't understand whether the compound is aromatic or not aromatic, so let's take an example here. Here is the benzene and benzenium ion. Okay, here is the orbital diagram. You can see here that all the p orbitals unhybridized and perpendicular to the sp2 hybridized orbitals. Okay, I am only showing you the unhybridized p orbital that are perpendicular. All the p orbitals are parallel to each other. Okay, and here also they are parallel to each other. Okay, but here you can see something different, that is negative charge p orbital, or okay, in which 2 electrons are exist. Okay, it is the orbital of the carbon. Okay, because carbon connect with the hydrogen and hydrogen will remove and carbon will get negative charge, but this orbital is not parallel to this p orbital. Okay, you can see simply here this p orbital is not perpendicular to this p orbital or any of the orbital. Okay, so we have know about it that parallel to each other and separated by 1 sigma bond is required for conjugation, but here it cannot take part in conjugation. Okay, so how many p orbitals take part in conjugation? That this 6, and here also this 6. Okay, so orbitals are in conjugation and also in delocalization. Okay, so we can see simply 3 pi bonds, and here also 3 pi bonds are delocalized. This negative charge cannot delocalize. Why? Because it is not in conjugation, and delocalization must happen if the negative charge will be in conjugation, so there will be delocalization. Remember this thing in your mind. Okay, so here only 3 pi bonds are in conjugation and delocalization, so there are only 6 pi electrons in both of these systems. And remember this thing, Huckel rule. Also you should remember the Huckel rule. 6 pi electrons are delocalized, but according to they follow the Huckel rule or not? Let's go into it. 4n plus 2 is equal to 6, and count the value of n. You will get 1, and it is integer value. So this both of these systems are cyclic, having conjugated delocalized pi system, and 4n plus 2 pi electrons, and it is flat. Okay, you know, because all the carbon are sp2 hybridized carbon. Let's go into the another example. Here you can see that nitrogen have lone pair, but also you can see here in orbital diagram that this lone pair are not in conjugation because it is not parallel to the p orbital. Okay, so how many pi bonds? 3 pi bonds and 6 pi electrons. Okay, so 6 pi electrons follows the Huckel rule. Okay, and it is cyclic, delocalized, conjugated pi system. Why? Because they are parallel to each other, all of the p orbitals except this p orbit. Okay, hybridized orbital here this. So it is flat molecule and 4n plus 2 pi electrons. It is aromatic. Next example. Simply pause the video and count and solve it on your own, whether it is aromatic, not aromatic, or anti-aromatic. Simply solve it. Okay. Simply solve it that it is aromatic or not aromatic. Pause the video and solve it. So I am solving it out, okay, and you think that this compound is not aromatic. Okay, you think about it. Why? Because it have 4 pi electrons, and you count the value of n also, and you can think that Hugel is not follow, it is not aromatic, but you are wrong. Okay, you are wrong, simply wrong. Why? Because there are 2 lone pairs here. Okay, here only 1 lone pair in the nitrogen, but here oxygen there are 2 lone pairs, and in this 1 lone pair is parallel to the p orbital and separated by 1 sigma bond, so it will be in conjugation, and we will see delocalization of the pi bonds and also this lone pair also. So we have delocalized conjugated pi system, and how many pi electrons? 2 in pi bonds, and this lone pair also we should count as a pi electron. So 6 pi electrons are conjugated and delocalized, and this p orbit having 2 electrons lone pair cannot take part in conjugation due to the perpendicular to the p orbital. Okay, I know you understand very well about it. Okay, if you like my video, please like it and subscribe to my channel. I will make the video on about this system and organic chemistry, all about the chemistry video. Okay, so let's go into the another example, cyclopentadienylalanine. You can see simply here also that carbon will have negative charge. You can see that pi bonds, 2 pi bonds here and 4 pi electrons, but remember this negative charge also, that negative charge having 2 electrons like this. Okay, and carbon make the bond with 2 carbons and also with this hydrogen. Okay, but remaining p orbital is parallel to the p orbital, another p orbital, and separated by 1 sigma bond, so it will be delocalized. So how many pi electrons? 6 pi electrons. It is planar, it is 4 pi electrons, and it is a cyclic, or it follows the 4 rules. Okay, so it is aromatic compound. Remember one thing. Okay, it is stable anion. Go to the such type of carbocation, tropylium ion. Okay, tropylium cation, you can see here, and simply solve it on your own. Okay, you think that it is not aromatic. Why? You think that here it is not flat molecule, here carbon have sp3 hybridization, you think. Okay, but you are wrong. Why? Because this carbon have sp2 hybridization. Okay, and this sp2 hybridization make the bond with 2 carbons like this. You can see here and here. There will be H like this. It have 2 H. Okay, but 1 H removed, and carbon, sorry, it have 1 H and another is Cl like this. First Cl, or another electronegative element. When this electronegative element removed, carbon will get positive charge. Okay, and remaining vacant p orbital will be perpendicular to the sp2 hybridized orbitals or to the plane like this. You can see here. Okay, I'm removing this. Okay, so you can understand that vacant p orbital is parallel to the all the p orbitals. Okay, you can see here, this is the vacant p orbital of carbon which have positive charge. So this p orbital also take part in conjugation. It have not any electron, but it will take part in conjugation. Okay, how? Let's go into it and we can see it like this. First of all, this bond, then this bond, and then this bond. Okay, you can see simply here, and this is vacant p orbital. But remember one thing, that here you can see that this pi bond will go here. Okay, then this pi bond come here. Okay, simply a resonance. Okay, I'm drawing the resonating structure. Okay, so you can see here that this positive charge will come here. Okay, I'm showing you the animation or resonating structure like this. First pi bond come here, then pi bond come here, then pi bond come here. Positive charge will come here. So in the way, the positive charge also delocalized. Why? Because it will be in conjugation. Okay, so it is delocalized system. Okay, it have conjugation, it is cyclic, it is planar, and how many pi electrons? 2, 2 and 2, 6 pi electrons. Here carbon have vacant p orbital, so we can't count any of the electrons. Okay, so 6 pi electrons, and it is aromatic compound. It follows all the rules. Okay, I hope you understand all about the things. So remember one thing, that if you stuck any of the question that how many pi electrons should I count So remember one thing, that if there are negative charge, so you should count the negative charge in the conjugation. Okay, you can see simply here. You can simply see the negative charge here not count as a conjugation. Why? Because carbon have negative charge, but this pi bond or this negatively charged anion is not perpendicular to the p orbital. Okay, you should remember this thing. Okay, and when here you can see a lone pair. Okay, but n have 3 valency. Okay, so all the 3 valency are satisfied, and one lone pair will be in the perpendicular to the p orbital. Okay, so simply count these about the this thing. Remember, remind this in your mind, so you can solve the examples. Okay, so I hope you understand about it, that if there are 2 lone pairs, one lone pair always and usually will be in the delocalization. Okay.